Hello guys, welcome to my YouTube channel Study Cool.
In this video, I'm going to explain about limit of a sequence and related problems. So first, let us see the definition of a limit of a sequence. A sequence Sn of real numbers is said to be converge to the real numbers S, provided that for each epsilon greater than 0, there exists a number n such that n is greater than n implies mod Sn minus S is less than epsilon, then Sn converges to S similarly. Limit n tends to infinity Sn equal to S can also be written as Sn converges to S, or simply we can write this definition in a single sentence like this. For each epsilon greater than 0, there exists n is greater than n such that S mod Sn minus S is less than epsilon. So remember this one, if for a sequence limit exists, which means, so like this, limit n tends to infinity Sn equal to S, which means for a sequence Sn there exists a limit. So then we can say that Sn is converges to S. So now let's see some related questions. So Sn equal to 3n plus 1 divided by 7n minus 4. Here we need to find the limit for the sequence. To find the limit, here we need to substitute infinity in place of n. So if we substitute infinity, 3 into infinity plus 1 divided by 7 into infinity minus 4. So something into infinity is infinity and plus 1 is also infinity, and divided by 7 into infinity is infinity minus 4. If we subtract any number from larger value, then the value will be larger only. So here infinity. So infinity by infinity is undetermined form. So it's wrong form. So that's why we need to take the n common here. To avoid this undetermined form, we need to take n common from the numerator and we need to cancel it. So here we'll do like this. Sn equal to n into 3 plus 1 by n. Because if we cancel n and n, we'll get 1 as it is. So again in denominator also. N into 7 minus 4 by n. And here we can cancel n and n in numerator and denominator. So now we need to apply limits. So apply limits, that is n tends to infinity. So limit n tends to infinity Sn, which is equal to limit n tends to infinity 3 plus 1 by n divided by 7 minus 4 by n. As n tends to infinity, 1 by n, which is equal to 1 by infinity. So something by infinity is always 0. Remember this one. This is very much important one. So limit n tends to infinity Sn equal to 3 plus 1 by n. So 1 by infinity is 0 divided by 7 minus 4 by infinity, which is 0. So 3 by 7. So the answer is 3 by 7. So now we'll write Sn converges to 3 by 7. So now Sn converges to 3 by 7. As limit exists, we can say that sequence is a convergent sequence. So always remember that a sequence should have a unique value. So unique value, which means 3 by 7 or 0 or 1, like this. It should have a unique value, but it should not equal to infinity. If it is equal to infinity, then limit does not exist. Limit does not exist. Now let's do another question. Sn equal to 1 by n square. Here also we need to substitute infinity in place of n. So here n is in denominator, so no need of cancelling it, just we need to substitute infinity in place of n, that's it. So limit n tends to infinity Sn equal to limit n tends to infinity 1 by n square. So 1 by infinity square. So infinity is in denominator. So again the value is 0. So limit n tends to infinity Sn equals to 0. So Sn converges to S. So here also limit exists and it is a convergent sequence. Now let's do another question. An equal to minus 1 whole to the power n. So limit n tends to infinity an equal to limit n tends to infinity of minus 1 whole to the power n. So here we need to consider two cases. When n equal to even number and when n is equal to odd number. So when n is odd, then limit n tends to infinity is equal to minus 1. Why? Because if we are considering odd numbers like 1, 3, 5, so minus 1 whole to the power 1 is minus 1 and minus 1 whole to the power cube is also minus 1. So when we are keeping odd numbers in place of n, we are getting odd numbers, and when n is even, then limit n tends to infinity is equal to plus 1. So here limit does not exist because the limit values are not unique, because we got minus 1 and plus 1, two numbers, right? So limit does not exist. Limit does not exist. Therefore, given sequence is not convergent. Let's see another question. Cn equal to 2 to the power minus n. So here 2 to the power minus n can be written as 1 by 2 power n. So now here also we need to find the limit. Limit n tends to infinity, Cn equal to limit n tends to infinity 1 by 2 power n. If we substitute infinity in place of n, then we'll get 1 by 2 power infinity. So 2 power infinity is infinity. So 1 by infinity, which is equal to 0. So limit n tends to infinity Cn equal to 0, which means Cn converges to 0. So here the limit value is unique. So we can say that limit exists and the sequence is convergent sequence. This is another question. Now it's your turn. Find the answer for this question, whether it is a convergent sequence or not. Let me know your answer in the comment section. I hope you like this video and don't forget to share it to your friends and let me know your questions in the comment section. Daily I will upload a long video and shorts, and in that short video I will upload an important question. And like, share and subscribe to my channel Study Cool. So don't forget to press the bell icon to get the notifications.